All right, good day everyone. This is Jason Strait with the CloudPass Virtual Group. Our presentation today is SQL Server to Azure SQL availability. And our presenter is Anna Hoffman. Before I hand things over to her though, we're just gonna go through a few announcements. There we go. First, this virtual group is sponsored by Microsoft Azure. Microsoft sponsors the virtual group and hopes to help folks learn more about the availability of data platform options on the Microsoft Azure platform. And so since most of our sessions do focus around that, it's probably a pretty good pairing. If you are not yet a member of our virtual group, I do recommend going out and becoming a member. Doing so is pretty easy. Just go up to cloud.pass.org, and then there's a login and a subscribe button that's in the center of the banner. And once you do that, you'll get access to the newsletter that comes on a fairly regular basis and lets you know about upcoming sessions. In regards to upcoming sessions, we have quite a few in the pipeline. Right now, between now and the end of March, I believe that we have 25 or 26 sessions already scheduled, with more sessions on their way. One session I do want to highlight that just got added today is Data Engineering 101 with Leslie Andrews. That's coming up December 22nd. So that one, and plus all the other ones listed on the screen, are some of the sessions coming up here in the next couple of months. Even though we do have quite a few sessions, we are always looking for more presenters. That's always great to have different viewpoints on different building out cloud platforms. And so if you are interested in speaking, you can go out to cloud.pass.org and click on the link for the call for speakers. Alternatively, if you want to keep it pretty simple, you can actually just email me too at cloud@pass.org, and we'll work through all the details to get you on the schedule as well. Coming up in 2 weeks is Virtual Pass Summit 2020. Due to circumstances this year, it's going to be an all virtual pass summit. If you have not yet registered, you can get a discount on your registration by using the discount code that's there on the screen. This virtual group is part of a number of virtual groups that PASS helps to support to help people learn more about building out data platforms. Some of these focus on different aspects of data platforms like data science and virtualization. Others focus on subsets of languages such as Global Chinese and Global Italian. These sessions are all set around to kind of help people focus in and learn the most that they can. Throughout the session, I expect that a few of you will have some questions, and if you do, please type them into the question panel on the GoToWebinar window. And by doing so, we'll put those questions into the queue, and then at the end of the session, time permitting, we'll go through as many as possible. And with that, those are all the announcements today. So I'm going to turn things over to Anna for her session today, SQL Server to Azure SQL availability.
Thanks, Jason. I am excited to be here. Let me share my screen. Can you see? I don't know which screen you can see. The right screen, this screen?
Yep, where the mouse is.
Okay, awesome, perfect. Okay, well, thank you all for joining me today. Some of you might remember, Jason and I were actually talking about this before the call, that I was on this virtual group, or in this virtual group, presenting to this virtual group back in June, which to Jason, he said it feels like forever, and to me, I'm kind of on the fence about whether it feels like it was just yesterday or if it actually feels like it was a long time ago. So either way, I'm happy to be back. Last time we talked about Azure SQL, what to use when. I'm going to spend just a tiny bit of time talking about that, just in case you weren't in that session or need a brief refresher. And then we're going to dive into some of the availability options available in Azure SQL Database and Azure SQL Managed Instance. And, you know, this is part of a series that myself and Bob Ward have been doing called SQL Server to Azure SQL. And so we do topics like security, performance, availability. Today is obviously the availability session. And I'll share lots of resources if you actually want to see the content for all of those SQL Server to Azure SQLs, because really our goal is to help SQL Server professionals which is probably most of you on the call, translate your skills to Azure SQL and also see the benefits and also see, you know, how the DBA is still very useful and very required in this new space. Okay, so for the agenda for today, we'll talk about an overview, and then we're going to talk about different layers of availability. We'll talk about some scenarios, and then I'll give way more resources than you could ever want to check out. And we do have a few demos that are planned. So when we get to a demo, if you have a question, maybe Jason can help read the questions and we can kind of take them in chunks, and then also any remaining questions at the end. All right, so let's get started. So Azure SQL, as you hopefully know, is basically our name for any SQL product running in Azure. And so we have three main deployment options. The first is SQL Server and Azure Virtual Machine, and this is exactly what it sounds like. It's just SQL Server and it's an Azure Virtual Machine. So you get to pick the SQL Server version, you get to pick the OS in the version, you get to pick your license. You could bring your license, bring your own license, and you know, this is really just SQL Server. So if you need access to the OS, this is the way to go. Now, if we abstract away the OS and say, you know, I just want to manage SQL Server, and I also want a platform as a service, so I want things like versionless SQL Server. I never want to have to do an upgrade again, but I still need instance scope features like ML services, CLR, DTC now, which is pretty new, service broker, database mail, etc. Those instance scope features are available in Azure SQL Managed Instance, which makes it easier to migrate potentially from your on-prem environment. And then finally, if we abstract away the instance level feature and say, I just want a database, start building new intelligent applications, maybe taking advantage of things like serverless and Hyperscale, then Azure SQL Database is the way to go. So this is kind of the overview. And today we're going to be focusing on high availability options for Azure SQL Managed Instance and Azure SQL Database. Now, typically, you know, when you think about database availability, you don't think about backups and restore or disaster recovery types of scenarios. But I just felt like I couldn't talk about this without also mentioning backups. So just very briefly, when we talk about Azure SQL Managed Instance and Azure SQL Database, we do a full database backup once a week with log backups every 5 to 10 minutes. And diff backups you see 12 to 24 hours. Additionally, you have the choice, this is new, as of like the last month or so, you have the choice of where those backups reside. They used to be by default in geo-redundant storage, so in your region as well as the paired region. So for example, East US, West US. But some countries don't have two regions. So for data sovereignty purposes, you might want to not have GRS. So we recently announced options for locally redundant storage. So, you know, having your copies right there in the data center on that machine versus zone redundant storage, which we'll talk more about and you'll learn about what that means. We're going to talk a lot about availability zones today. We also do things like backup integrity checks. We'll occasionally test the restore capability. We also allow you to do a point-in-time restore, but you can't restore on top of an existing database like you might in SQL Server. And we do that to protect you. You restore to a new database, you make sure it's where you want to be, and then you can do, you know, a name-changing operation to replace the other database. So that's kind of like the gist of backup restore. There's options for keeping your backups between 1 and 35 days, and if 35 days isn't enough, you can even opt for things like long-term retention for up to 10 years of backups, and you can even restore a deleted database. So I just felt like I had to mention backup restore. I know I went really fast there, but now I want to shift to our main topic, which is really the layers of availability. And some of this is DR, but I think for the most part, it will be HA. So if we look at the first layer, we think about local redundancy. So this would be within a data center, a single data center or a single building in a data center in a region. So that's local redundancy. So do we have copies of the data locally? Then we're going to talk about zone redundancy. So within a region, there are multiple data centers, multiple buildings. And so this idea of zone redundancy is spreading your redundancy across different zones or different data centers, different buildings in a region. And then finally, we have geo redundancy, which is as you might guess, like now not only just being redundant in your local and zone, but also globally in another region, do you have some redundancy there as well? And this is really important for your disaster recovery type of scenarios. All right, so we're going to start with the first layer, which is local. Then we'll go through the others. And the way I'm going to do this is by talking about the different architectures for availability underneath the vCore model service tiers. So the first service tier is general purpose. And those of you familiar with Azure SQL Database and Managed Instance, this is the most commonly deployed service tier. It's meant for what the name suggests, general purpose. So just your general workloads in SQL Azure. And if you look at the architecture, what you're going to notice is that it behaves kind of like a failover cluster instance. But even before that, what you're going to have is you're going to have an application. It's going to go to the gateway to figure out how to connect to the database, and then you're going to be connected to the primary replica, which has the TempDB running on locally attached SSD. And then the data and log files are actually going to be in Azure Premium Storage, so it's easier and faster for us to access, but it is not directly attached. And this is locally redundant storage, so that means there's multiple copies of it in the building where it resides. And then finally, your backups, like I mentioned, are going to be in geo-redundant storage by default, but you could set this up to be locally redundant storage or zone redundant storage as well. So now if you think about a failover, so let's back up a second. So all these services are running on the Azure backbone, and this Azure backbone for the most part is made up of Azure Service Fabric. And so all these applications, Azure SQL Database, Azure SQL Managed Instance, are running with Azure Service Fabric underneath. Now, if Azure Service Fabric decides that something is awry and we need to fail you over, what we can do is we can look for a node with spare capacity, fail you over, and then reattach that TempDB to the data and log files and get you back up and running. Now, we take care of all of this redirection for you. So as long as you have retry logic in your application, which is very important when you move to the cloud, you might see a blip in performance as we change you over. It can take a little bit longer than some of the other options we'll talk about because we don't have like a spare compute that's hot and standing by. All right, so now the next service tier we're going to talk about is general purpose. And what you can see is we kind of have the same general setup here as we have our gateway and our primary replica, except now on the primary replica, not only do you have TempDB running on directly attached SSD, but you also have the data and the log files as opposed to them running in Azure Premium Storage in the general purpose tier. And what we also do is we behind the scenes deploy an always on availability group for you. So this means you're going to have 3 secondary replicas at any given time, and we even allow you to read from one of these secondary replicas. Your backups, just as with general purpose, are stored in geo-redundant storage by default, but you can configure this for locally redundant or zone redundant type of storage. Now let's think about the scenario we talked about earlier where Azure Service Fabric decides, hey, you know, we kind of need to fail you over for whatever reason, or you yourself want to force a failover. This can happen very quickly because all we have to do is kind of take care of the redirections to point you to one of the secondary replicas. And then in the meantime, we can spin up, in the background, we can spin up an additional secondary replica for you. So this can be much faster than failing over in general purpose. But either way, between both of these service tiers, the failover is very fast. So I thought this would be kind of a cool opportunity to see a demo of this in action, how fast these failovers can be. And, you know, I do want to stress that, you know, we didn't have to do anything here. Like we just deploy general purpose, we just deploy business critical, and we get this type of availability. So what you can see on my screen is a lot of things, hopefully. This is Azure Data Studio, great tool. If you haven't used it before, I highly recommend downloading it and playing with it. It now comes with SSMS. But what I like to use is the notebook capability, and you see there's lots of different kernels I can use. I'm using the PowerShell. It's probably the one I use the most, honestly, and so this is good for all things Azure. It doesn't necessarily have to be Azure SQL as well. But the great thing is I can combine code cells with text cells, and I no longer even have to know Markdown. I can just write write the text I want and use, standard formatting UI. Okay, so that's Azure Data Studio. So let's look at what we have. On the right side, we have business critical. On the left side, we have general purpose. So down in the bottom right, what I'm doing is I'm using OStress, which maybe some of you have seen, basically a tool to create a workload. And I'm querying this database. It's a very simple query on an AdventureWorks database running in the business critical service tier. And so if we run that, all we see is 847. So this just means that the database is available and we keep hitting it and it's still available. So this is my business critical database. On the left-hand side, I have the same query, except this time it's running on a general purpose database. So what I can see is I'm getting the same results from both, and we're just using this to kind of query the availability of both of the databases. Now, what I'm going to do is we're going to force a failover. You can do this in Azure PowerShell. Force a failover on the business critical database and the general purpose database and see what happens to our availability. So remember, right is business critical, left general purpose. So let me kick that off. Okay, so what we see is pretty much immediately the business critical database became unavailable. And what you'll usually see, and shortly after that, the general purpose database followed as well. Now what you'll usually see, and there we go, we have it, is that the business critical database will fail over and be back up and running between 2 and 8 seconds. So this one seemed closer to 8 seconds, but I've seen where it's really like, just lightning fast, just like 2 seconds. And then the general purpose database takes a little bit longer. In my experience, it takes around 30 seconds. But what's so powerful here? Let's talk about a few things. So for business critical, it is much faster. And the reason for this is we do have that secondary compute standing by, right? So we just have to do some redirection and you have to go back to the gateway, but you don't have to change anything in your application, and then you're back up and running. With general purpose, it takes just a little bit longer because we don't have that hot secondary standing by. So we have to go look for a node with spare capacity, fail you over to that one, and then redirect to your data and log files. But either way, what you saw is those failovers happen really fast. And this thing that I want to stress is that I really didn't have to do anything, right? I just deployed a business critical database. I just deployed a general purpose database. I didn't have to deploy an always on availability group, which is very complicated, or a failover cluster instance. So this is one of the things I say, like the power of platform as a service, or the power of PaaS. So hopefully that was an interesting demo. I will share how I did that in the resources. So if you want to try this out on your own and actually see what it looks like for your environment or for just general curiosity, you can do that. So that's business critical. And I'll take a second to ask Jason, do we have any questions?
The only question we have so far is whether or not this is being recorded, and yes, it is.
It is.
Because that's the first few minutes.
Okay, awesome. Thanks, Jason. Keep your questions coming in. We'll take a look at the questions again in the next demo. All right, so we talked about business critical. We talked about general purpose. The last service tier I want to talk about, which is only available in Azure SQL Database today, not in managed instance, something we're actively working on, but it's not quite there yet, is Hyperscale. And so Hyperscale is really interesting because what we did is we re-architected SQL Server for the cloud. So we basically took SQL Server apart and made it a cloud-born type of architecture. So what you can see are a few things. We have our compute layer. So you have a primary compute, and then you have optional secondary compute. So by default, we deploy 1 replica, but you can have 0 replicas, and you can also have 4 replicas. So this is going to allow you to get read scale based on your requirements. You can actually scale up or scale down these services. And additionally, what we have is we have the page server. So you can see the page servers are in a different layer. So we're using a layer of caching systems. And this page server layer is actually full covering. And so this is really awesome. This is, for a number of reasons, going to make us be able to do things faster. For example, what we have, you can see in Azure Standard Storage, is we keep the data files separate, and we're able to do snapshot backups, which means we can do nearly instantaneous backups. We can also do restores in constant time. So what that means is that regardless of your database size, so whether it's 10 terabytes or 50 terabytes, we can restore you in a matter of minutes in constant time. It's no longer a size of data operation, which is really awesome. Now, the other thing I wanted to mention is that we completely pulled out the log service, which is what you're seeing, and the log service is going to feed the replicas. And so what that means is that transactions can actually commit when the log service hardens to the log landing zone. So that means that this consumption of the changes by the secondary compute is not required for transaction commit. The log service can feed them after transaction commit, so or replay them. This isn't using always on availability groups like we saw with business critical, but it is a similar technology that allows the log records to feed those changes to the secondary replicas. Now, if we think about a failover like we talked about in the other scenarios, this is going to depend on the existence of replicas. So if you have 0 replicas, you could imagine that it's going to behave somewhat similar to what you saw with general purpose. And if you have multiple replicas, what we're going to be able to do, if you have 1 or 2 or more replicas, it is going to make us be able to fail you over faster because you do have this hot secondary compute standing by. I talked a little bit about backups already and your recovery time. All right, so now what we have is a brief demo. This is really brief. I just wanted to show you what the impact of having this much read scale can do for your workloads. So what I have here is I have a Hyperscale database, and right now I'm just using the main endpoint, so the read-write endpoint. So you can see I'm able to insert a certain number of events per second. And then on the right side, what you also see is I'm using SQL query stress. This is another cool tool for inducing a load. And I'm saying, you know, this is a read workload, but I'm hitting the read-write endpoint. So what happens when I run this is that it's actually going to take a toll on my write-only workload. So this events per second is going to go down in this case. And that's going to happen for the duration of my read workload. So this read workload is impacting my primary, which is less than ideal, right? So now that finishes, I can show you what I've actually done is I scaled up to 4 readable replicas. And so now if I go back, what I can do is I pulled up 4 more query stress windows, just because this was the easiest way to show that we can do 4 times as much workload. And what I'm doing is in each of these, I'm using the application intent read only. So you can see there, as well as in this one and the final one. So what this allows me to do is do 4 times the amount of work, and this is the read-write endpoint. I'm just gonna close that one. But if I kick these off, what I can see is I'm able to do 4 times the amount of read workload per se, and not impact my primary. So this is pretty big, especially if you do have like sizable operations like generally happening on your database, but you also want to do some reporting on the side. You can do this without impacting your write workload. So that's just like a brief demo there that I think is sometimes cool to see how read scale out works. So, you know, we talked about the different service tiers. We talked about general purpose, how it's kind of like a failover cluster instance. We talked about business critical, how it's more of like an always on availability group. We talked about hyperscale, how it's really been re-architected for the cloud. So it has this idea of unlimited storage. We say up to 100 terabytes, but there's nothing architecturally limiting us like it is in general purpose or business critical, where we're constrained by the hardware and the node that we have available. And so, you know, I put this together just to compare the different service tiers, and maybe you've seen this before from me, but you can see kind of the IO per second or IOPS, how it compares, how the price compares, and some of the other considerations, like serverless is only available in the general purpose service tier in SQL database, not in managed instance yet. In-memory OLTP, if you have that type of workload, only allowed in business critical today. And, you know, of course, to get above that 4 terabytes or 8 terabyte size limit, you have to move towards the hyperscale tier. So that's kind of what we have going on at a local level. And I know I said I would take questions at the next demo and I forgot. So I'm going to pause before we go into zone redundancy and ask if there are any more questions to address.
The only one that came in was asking about how long does it take to do a failover, and that was right before you mentioned it just takes a couple of minutes. I don't know if you wanted to expand on that at all.
Yeah, sure. So a failover is what we saw in the demo. And so for general purpose, the failover took about 30 seconds. And from my experience, that's pretty standard. And then for business critical, the failover took, I think it took about 8 seconds this time, but I've seen it as fast as like 1 or 2 seconds. So it depends. And those are based on the service tier, not based on the deployment option. So the demo was for SQL database, but you should see similar times for SQL managed instance as well. That's a good question.
Okay.
Awesome.
And then for business critical, is the failover always local, or can you specify it for a different region?
Yeah, that's a great question. So for business critical, is the failover always local, or can you specify it for a different region? If you have geo redundancy set up, which we will talk about, then you can specify whether or not you want to failover in your region, or if you want to failover to another region. So we will get to that, and hopefully that'll help clear that up as well.
Great. The only other question was on the same vein, so I'll just skip over that.
Okay, awesome. Thanks, Jason. Keep them coming. Okay, so we talked about local. Now we're going to talk about zone redundancy. So I first want to back up and talk about what is an availability zones, because they're relatively new in Azure, but I think you'll start to see them expanding more and more and more as we go forward. So basically what an availability zone requires is that there are a minimum of 3 physically separated locations. So if we had a region, so if we take like West US, for example, and I don't know where the data centers are, but let's say we take the 3 states, let's say there's a data center in Washington, Oregon, and California. What this availability zone would do is it would mean that you could be spread across 3 different locations within a region. Now, perhaps these could be different buildings within a data center, but the requirement is that they have to have independent power, cooling, and network. So if they're in the same data center, they'd be in different buildings and have their own system. And this is really meant to protect you against data center or building level outages. And then these Azure management services are going to be replicated across zones. And we're also going to orchestrate all of that for you so you don't have to worry about it. Now, if we look at what this might look like for some of the different service tiers, currently it's only available in business critical and then in a limited capacity in general purpose. But if we look at business critical, we remember that we have, let me get my laser pointer. We remember that we have our primary replica for business critical in our always on availability group. And so what we're going to do is we're going to spread those replicas across 3 different availability zones. So that means these would be in different buildings or different data centers, but still in the same availability group. Now, all of this that you're seeing is stuff you don't have to worry about. So we set up Azure Traffic Manager. You just connect to your application like you would otherwise. And instead of going to just the main gateway in the control ring, Azure Traffic Manager is going to take care of sending you to the respective zone. And then, again, by default, those backups are stored in geo-redundant storage, but you can change that. Now, when a failover occurs, again, this can be very fast because we already have the hot compute standing by. But we can see that it would fail over to a different zone. Now, you don't have control over which zone we fail you over to. We actually don't even give you any visibility into where your availability zones are or where your primary is sitting. So this is something you don't have a control over, and it's really meant to kind of make that easier for you. You just know you're spread across different data centers and you're protected against some sort of zonal outage. So if, this whole data center goes down or building goes down, you can be sure that we'll fail you over to this, or we can fail you over to this zone. Oh, and the other thing I wanted to mention is that this is free for business critical and premium service tiers, but it's not on by default. So my recommendation and the recommendation generally from our team is that you should turn this on because it's going to protect you against zonal level outages. Now, the next thing that was very recently announced, you can see announced on 10/22, which was just a few days ago, is the general purpose service tier for zone redundancy in preview. And so if we think about this architecture, how we have our TempDB here, it's a little less simple than what you see in an availability group with business critical, because we don't have other replicas standing by. So what we do is we take your data and log files, and instead of storing them in locally redundant storage, which would just be here, we actually store them in zone redundant storage, so your data and log files are available across the 3 availability zones. Of course, your backups are still stored in the way that you want them. You get to pick if this is locally, zone, or geo. And then if we need to do a failover, what we have to do is very similar to what you saw before, is we have to look for a node with spare capacity in a different zone. We fail you over to that, and then we reconnect you to the data and log, the zone redundant data and log files. And this arrow is not necessarily representative of which zone it's going to. And similarly, for if we had to fail you over to this other region, we would also do that as well. Now, since this is so new, I'm not exactly sure how the pricing for that is going to work. So I just wanted to be completely candid with that. You should check the pricing pages to learn the exact details. But this is going to protect you against zonal outage. And from a timing perspective, it'll still take about the same time from our testing to fail you over, because we just have to look for a node with spare capacity and then redirect those pointers. So from a process standpoint, nothing much changes as far as that goes. Okay, so we've talked about the local redundancy, we've talked about zonal redundancy, and now you're wondering, okay, how do I know, and is there any sort of guarantee that Microsoft has? Because like I mentioned, like you just get this, you sign up for this and you just get this type of availability. So what does it actually amount to? So we have an SLA, or a service level agreement, and I highly recommend that you go read our SLA because it's very interesting, and there are certain things you can set up to get the highest level of availability. And when I talk about highest level of availability, what I really mean is percentage of time of uptime. Okay, so what you can see is for a single zone, so if you don't have zone redundant configuration, you know, in most of our tiers you get 99.99% of availability, which is about 53 minutes of downtime per year, so not very much time at all. And one other interesting thing you'll see is depending on the number of replicas you have in Hyperscale depends your SLA. So you can see that, you know, obviously having more replicas is going to help us in failing you over faster, just like you saw with the always on availability groups. Now, if you want the highest SLA possible, you're going to get that by doing a zone redundant configuration in the premium or business critical tier. And so because of the always on availability group, because of our zone redundant configuration, we can keep you available against more disasters, and in less time we can get you back up and running. And this extra 0.005% basically means that instead of a maximum downtime of 53 minutes a year, you have a maximum downtime of about 26 minutes a year, which is, you know, really not very much time at all. It's like 2 minutes a month or something. Okay, so we've talked about local, we've talked about zone. The next layer is geo. So for Azure SQL Database and Azure SQL Managed Instance, there are really 2 options. And actually, when I talk about the details for Managed Instance, there's really only 1 option today. But those 2 options for Azure SQL Database are geo-replication and auto-failover groups. So let's kind of look at geo-replication. So what we do for geo-replication is you set up your primary, and then you would basically say you want to set up geo-replication to a database in another region or the same region, and you can also have multiple of these, and geo-replication works that way. Now, in the case of a failover, it's not automatic, which also means that you would have to go and change the connection strings. Okay, so or you need to have some sort of logic, maybe Azure Traffic Manager, that does that for you. Now, the big difference when we talk about auto failover groups, which is your other option, is that It is kind of using the always on availability group architecture underneath. So one thing related to this is that you can only have one. So with geo-replication, you can have multiple replicas in multiple locations around the globe, but with auto-failover groups, you can only pick one other region. And what you can see is we basically create a failover group. We do geo-replication between databases in that failover group, can be multiple databases in an Azure SQL database server or in an Azure SQL managed instance. But the big difference is that you get this read-write listener and read-only listener. So that means when a failover needs to occur, we'll take care of the redirection behind the scenes since you're only connecting to the listener. And so, this can be seamless and this can actually be automatic with no downtime, with no extra configuration. We just take care of redirecting those pointers for you. So I know sometimes these architecture diagrams can be a bit heavy. So I also have this table which compares and contrasts geo-replication versus auto-failover groups. So if we kind of look through these, I talked about how you get the automatic failover with auto-failover groups, not so much with geo-replication. With geo-replication, it's more of on a single database level, whereas with auto-failover groups, you can failover multiple databases at the same time. With geo-replication, we talked about this, you have to manually update your connection strings, but with auto-failover groups, you have these listeners, so you don't have to do this after a failover. Geo-replication is not currently supported today in managed instance, so that's something to be aware of. And if you want to have a replica in the same region, that's actually not allowed with auto-failover groups today. That could change in the future, but today that's the way it is. And both of these are going to support you in ReadScale. So I thought it would be interesting to take a look at an example, which you can also try yourselves for auto-failover groups. So I'm going to switch back to my VM. Let me just clean this up for a second, move some windows around, and we'll talk about it. That didn't really work. Okay, that's not great either. Sorry. Okay, I think we're good now. Failover groups. Okay, so what I have is, again, Azure Data Studio on the left with a PowerShell notebook. And then on the right, I have this Java application, which I'll talk a little bit more about. So let's see what we have. So I'm going to share this notebook with you all so you can run through all of these steps if you like, but you can see there were just 6 commands really involved in deploying an auto-failover group, setting up the connection between the different servers, replicating the data, and setting up the network so that my network had access to both of those servers in the case of a failover. So what I can do is I can use Azure PowerShell to get the replication role of what I'm calling the DR server. So I can see right now the DR server is in the replication role of secondary. And if I look in the Azure portal, I can see something similar here. I can see what I've labeled as my DR server is in the role of secondary, and the primary, which just doesn't have DR in the name, is in the role of primary. And actually, oops. If I turn this off, what you can see is my application, which I'll explain, isn't connecting to the actual actual servers. So you see it's not connecting to AWS server 0602 or 0602DR. It's connecting to the failover group listener. And so the primary, I just connect to this, and the secondary, or for read only, I just connect to this. And Azure is taking care of which database server I'm actually pointed to. So now if I go back to here, what you can see on the right is a very simple Java application. And what it's doing is it's basically trying to connect to the primary listener, so the primary listener of the failover group, and insert a row. And then it's trying to connect to the primary read-only listener, so the secondary, and try to read that row that was just inserted. So you can basically see it's saying both of those things are successful. Of course, this one has failed randomly. But anyway, so what I can do is I can use Azure PowerShell to actually kind of force this failover. So what I'm going to do is I use the switch command, and I basically say which server I want to become the primary. And so I'm saying I want the DR server to become the primary. If I switch over here fast enough, I might be able to catch it. We'll see. I might have to refresh the page to see that. Oh, actually, you know what? I missed it, because now you can see that the DR server is in the role of the primary as opposed to the secondary. So you can see that happened very quickly. I wasn't able to catch it. But for my application, I don't have to change my connection strings because I'm just connecting to these listeners. So if I go back to the app that we have, I can see we had 3 inserts and reads that were unsuccessful. You see they failed as that failover was taking place. And then I was back to being up and running. And I can also use PowerShell to check the status of that DR server and see that the DR server is in the primary role. And I can also see that in the Azure portal, as we saw. Now, similarly, I can choose to fail back, and we would see kind of the same experience. Let's see if we can catch it. It happens very quickly in this case because these databases are really, really small. So you can see it's failing over right now. It can tell me failover in progress. And then once the failover occurs, you can see that the DR server will go back to secondary, which it is, and my main server is in the primary role, but I didn't have to change any read-write listeners for my PowerShell application or Java application. It just suffered a few failures while the failover took place. So a few learnings from this. One, retry logic is super important, super, super important, because stuff like this happens with connectivity, whether you'll fail yourself over, there will be some issue and we fail you over. But these failovers are very brief, but you don't want them to amount in downtime. So you want to make sure that your application is ready for this sort of thing. And it kind of leads into my next point about making the right choices. So when I talk about the application being ready, one is retry logic. That's huge. And we have tons of guidance, sample code for you to leverage. There's a lot of libraries that exist that actually have kind of this system built in place that you can use. So retry logic is really important. Another thing to consider is not just the database, but also the application. So in this case, when I'm failing over to a new region, now what I have is my application in this region and my database in this region. And realistically, what you want is when your database fails over to another region, you want your application to fail over to that region as well, because latency is everything, right? Especially when we're talking about the cloud. So you really want those app and database to be as close as possible. When we talk about other choices, you want to think about your backup strategy. You want to think about your RTO and RPO needs. We actually do have an SLA for RTO and RPO depending on your geo redundancy. So again, you would want to read the Azure SQL SLA to learn more about that and how to get that SLA for RTO or RPO if that's something that you need. Read replicas is going to drive a lot of your decisions of not only the service tier, but even in the case of things like Hyperscale, how many readable replicas do you really need? You also have the option to kind of scale these readable replicas up and down as they are needed. So you don't have to maybe have them all the time, but maybe if you do a lot of reporting at the end of the month, it's a good idea to scale that up for that. We talked about zones in addition to local. We talked about zonal redundancy and we talked about geo redundancy. And so I'll take a minute to pause there and see if we have questions on zonal or geo or really anything we've done so far.
Yeah, so the one question I have that is, well, there's 2 questions, but the first one is, in this example, can they have 3 servers with 1, 2 as primary, secondary, and the 3rd server as DR, maybe in an async mode? Or is that even needed?
Sure. So in the scenario we were talking about over here, we have a primary, secondary, and the ask is if we have a 3rd one in async mode. So the failover groups, and I should have mentioned this, the failover groups are in async mode, but as well as geo-replication, but your local and zonal is in sync mode. So that's kind of the big difference between local zone, which is more of synchronous, versus geo, which is asynchronous. So it is possible that you could have, an Azure SQL database in the business critical service tier, which had zone redundancy configuration. So you have kind of that zonal protection in sync mode, and then you could have an auto failover group attached to this, which is going to give you that async server that's available. And we recommend that it's the same service tier, so that would also be a business critical service tier. So if you really think about it, you would have one readable endpoint in your primary from your business critical availability group, and then you would have 2 readable secondaries in your other region, which were async, but one would be the secondary endpoint for the failover group, and the other would be the readable replica that you get from the availability group in that failover group. So you can actually get, if you have business critical tier and you use auto failover groups with zone redundancy, you can have local redundancy, you can have zonal redundancy, and you can have this geo redundancy, and you can also have 3 readable replicas. So hopefully that helps. Sometimes it gets confusing when you start to think about that. A whiteboard would be great, but hopefully that helps answer your question.
Great. And then the other question that is there, and I think you talked about this briefly, but the costs regarding ZRS while configuring it, is there costs accumulated during configuration? And I think you mentioned. Okay.
Sure. That's a great question. So for the cost of zone redundancy, for business critical, there's no additional cost. So to me, there's really like not a big argument for why you wouldn't want to turn this on, because there's no additional cost associated. With general purpose, I'm not 100% sure on how pricing is going to work since this just launched last week in public preview. But if we take a look at the architecture and just think about it based on the architecture of a zone redundant database for general purpose, what we're doing with your data and log files is different what we do in the normal configuration. So in the normal configuration for general purpose without zone redundancy, we're using locally redundant storage. So all your storage is right there in the same machine, basically the same data center. Whereas with zonal redundant, we're actually, moving that data across 3 availability zones. So my guess, and again, this is Anna speaking, not Microsoft speaking, and I don't have all the answers. My guess is that there would be an additional storage cost related to the data and log files being across those availability zones. But again, don't quote me on that. I'm not sure. Your best bet is to visit those pricing pages and kind of stay tuned throughout the public preview to see what they decide to do.
Excellent. And that's all the questions we have at the moment.
Awesome. Thanks, Jason. So we just have a few more things left, and really the biggest thing is monitoring availability. And we could spend like days talking about all the different things you could monitor, might want to monitor, but at the highest level, I just wanted to mention the different things you could or might want to monitor in this new world of Azure SQL. So, you might want to monitor the region and data center availability. So, not only are, you can check basically the status of a given region, and this is all on public. I think if you just Bing or Google for Azure status, you can find the website that states the status of a given region, a given data center. It can also state the availability of a given service. If there's any issue with SQL DB all up in a certain region, you would see that there. You might also want to monitor the server availability, and there are different ways that you can do that using the portal, using PowerShell, using Azure CLI or REST. You might also want to in addition to the server availability, monitor the database availability, and you can do that in similar ways. You can check the backup restore history that you have, and you can even restore a backup yourself if you want to test that in the environment. You can restore it to a new database using the point-in-time restore capabilities. You can check the status of your replicas. So we actually have a few new DMV, so you can check the status of, for example, a replica in a geo-replication or an auto-failover group. So there's some new DMVs there. Let me see if I have them in my notes. Yes, it's the DMV, if you were wondering, is DM database replica states. And that's going to show the sync state of your database across geo-replication. And there are similar commands for Azure CLI like db replica list links, and you could see we could even query using Azure PowerShell what role the different database, what the different failover group status, primary, secondary is. And you might also want to query failover reasons. So like if this failover occurs, you might want to go investigate, well, what happened, or how can I know if it happened? Lots of tools available, like I was kind of mentioning, whether it's in the portal, whether it's in T-SQL, whether it's in the CLI, lots of tools available for you to learn how to monitor availability. And some of the resources I'll provide in just a moment, you can learn more about them. And then there's also a management pack. So if you are familiar with using SCOM, there is a management pack for Azure SQL Database and Azure SQL Managed Instance. I believe that went GA recently, but it has been a while available in public preview for a while. So if we look at a summary, we talked about a lot of things. We talked about backups, even though it's not necessarily, you know, depending who you talk to, strictly availability topic. We talked about the built-in high availability of Azure SQL Database and Azure SQL Managed Instance. You know, how we saw you can get faster failovers with business critical, but you get pretty darn fast failovers with just a general purpose type of database. We talked about the SLA and how you might think about if you need these situations, how you can kind of combine local, zone, and geo redundancy to get them the most available and disaster recovery proof database. But you also need to think about if you really need all of these things, depending on your application, depending on your use case. You know, a lot of these things, as we mentioned, are not free. Business critical is more expensive than general purpose. Zone redundancy for general purpose is more expensive than regular general purpose. Geo-replication and auto-failover groups are going to have costs associated with having those extra managed instance or databases deployed. So these are all considerations you want to make, but I hope that throughout this session, what you've learned is more guidance on what those options are and also how to think about those options. Now, there are lots of other resources for you to learn more. I just put them in this slide. If you want this deck, then the best place to go would be my GitHub, which is this aka.ms/analytics link. Just to briefly cover what resources are here, the first resource for SQL workshops is where myself, Buck Woody, Bob Ward, our whole team kind of hosts all of our content on GitHub. So if you want to find someone's presentation, for example, maybe Pedro Lopes did a presentation, you want to go find his deck, you can get to it from there. We also have workshops that you can take and redeliver, take yourself. There are slides you can steal. That's okay. That's why they're on GitHub. Lots of stuff there. The Azure SQL workshop has a ton of labs too related to this topic, as well as some of the other topics like performance, security, deploy and configure. And then we have our Microsoft Learning Path, which is going to allow you to get hands-on, which is huge, hands-on for free with Azure SQL. It's not quite developer edition, but it's pretty close to what you can get in the sandbox environment, which is free. Our docs are always a good place to go if you want to dive deeper into specific questions. And then if you like watching videos in this virtual world or hearing from me, Bob Ward and myself did a 61 video series called Azure SQL for Beginners. It's on YouTube. You can catch it at that link. And additionally, I host a show on Channel 9 and YouTube on Tuesdays and Thursdays. It's called Data Exposed, and I bring on MVPs as well as program managers and software engineers from our team, and we talk about some of the latest technology. We talk about what to use when, we talk about tips and tricks, we do demos, and we try to keep them short. So that's definitely something to subscribe to if you're interested. I know that was a ton of information to cover. I am happy to take questions now. I think we have some time remaining, but if you do have further questions, I'm going to find the chat and I think I can send this to everyone. I'm just going to put my email address in the chat. So if you do have specific questions that you think of later, feel free to reach out to me. I don't know the answer to everything, but I probably know someone that can answer your question. So thank you, Jason. Thank you, everyone. And I'll open it up for any questions.
Sure. There's one more question that came through. Is this auto failover groups an IaaS solution?
That's a great question. At this point, auto failover groups in the way that you see them in PaaS is not available in IaaS or SQL Server in Azure Virtual Machine. That being said, there is this new experience. You know, auto failover groups under the hood are using always on availability group technology. So if you wanted to use that method to get kind of the same experience in a virtual machine, we recently added, it's in public preview today, it's the ability to use a wizard to deploy an always on availability group for your SQL Server and Azure Virtual Machine, which, you know, you probably are familiar with how big of a pain setting up an always on availability group can be. So it's not the same as what you get with auto failover group where it's like click, 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 or like a few commands and then it's up and running. But I would say we're doing what we can to make that experience as painless as possible, even for SQL Server and Azure VM.
Excellent. And then the only other question was asking about the GitHub link, which I shared with everyone.
Awesome. Thank you, Jason. Thanks so much.
Yeah, and that's all we have for questions here today. Thank you everyone for attending, and thank you, Anna, for coming back. And hopefully we can get you back on here in a few or so.
Awesome. Thank you so much. Have a great one.
You too, and everyone else have a great rest of your day. Goodbye.